Me and my teammates, Apurv, Gaurav, and me, Zubair, are here for J component review. The J component title is Human Emotion Detection using OpenCV. I'll give the introduction about this project we are doing. Facial emotions are important factors in human communication that helps to understand the intentions of others. In general, people if infer the emotional state of other people, such as joy, sadness, and anger, using facial expressions and vocal tones. Facial expressions are one of the main information channels in interpersonal communication. Therefore, it is natural that facial emotions research has gained a lot of attention over the past decade with applications in perceptual and cognitive science. Interest in automatic emotion recognition, also known as FER as a short form, has also been increasing recently with rapid development of artificial intelligence techniques. They are now used in many applications, and their exposure to human is increasing to improve human computer interactions and make it more natural. Machines must be provided with the capability to understand the surrounding environment, especially the intentions of humans. Machines can capture their environment state through cameras and sensors. In recent years, deep learning algorithms have proven to be very successful in capturing environment states. Emotion detection is necessary for machines to be better service and serve their purpose, since they deliver information about the inner state of humans. A machine can be used as a sequence of facial images with DL techniques to determine human emotions.
Now I'll talk about the methodology we have used in this project. So first, the input image is passed through a standard convolution layer, then through a 9 DSC layer and 4 improved DSC layers in turn. Finally, the features are extracted through the average pool layer and a fully connected layer. In order to better identify the features and make the network coverage quickly, it is necessary to perform a BN layer and ReLU 6 non-linear activation function processing on the output of each pointwise to the convolution layer to improve the non-linear expression ability. In the depth-wise convolution layer, to retain the information as much as possible, it only passes through the BN layer without adding a non-linear activation function. It adopts a linear output, that is, of all the original mobile net model, and the improved deep separable convolution layer were adopted. The core idea of mobile net V1 network is to replace the standard convolution operation with depth-wise separable convolution to reduce the model parameter. Specifically, DSC is to use the 3x3 convolution kernel with only one layer thickness, sliding layer by layer on the input tensor, and to generate an output channel after each convolution. When the convolution was complete, we use a 1x1 pointwise convolution to adjust the thickness as shown in the figure. However, the mobile net V1 introduces a ReLU activation function after the deep convolution layer, which cannot change the number of channels. The extracted features are single channels, and the operation of the ReLU in the CNN output with the fewer channels will lead to information loss. To this end, we propose an improved depth-wise separable CNN. That is, after the depth-wise convolution, the linear output was adopted, and the attention module is added after the point-wise convolution. The rest is consistent with the DSC layer in the mobile net V1. For the mobile nets, the depth-wise convolution applies a single filter to each input, and the point-wise convolution then applies a 1x1 convolution to combine the output with the depth-wise convolution. A standard convolution both filters and combines the input into a new set of output in one step. The depth-wise separable convolution splits it into two layers, a separate layer for filtering and one separate layer for combining. The factorization has the effects of drastically reducing the computation and model size. It is also very low maintenance, thus performing quite well with a high speed. There are also many flavors of pre-trained model with the size of network in memory and on disk being proportional to the number of parameters being used. The speed and the power consumption of the network is proportional to the number of max, that is the multiple accumulates, which is the measure of the number of fuse multiplication application. The architecture consists of, first it is a 3x3 depth-wise convolution layer, then the BN layer, that is linear, then 1x1 pointwise convolution, then again a BN layer, then ReLU 6 function, and then channel attention and the spatial attention. Now Zubair will talk about the dataset.
So the experimental datasets used FER plus and RAFDB, both collected from the internet and contain unconstrained facial expression images. Sample images of each database table illustrates the amount of each expressions taken from FER plus and RAFDB. The feature is change can pay module in the mobile net V1 network model. Attention mechanism can improve the feature expression ability to of the deep network. The attention module CBAM is in the convolution layer is a lightweight attention module which can conduct attention in channel and spatial dimensions. In most cases, the parameters and computation of cost of CBAM module can be ignored. The CBAM mainly performs the following two operations on it, where F represents the input feature. The operator represents element-wise dot multiplication. Uh, MC and MS represents attention extraction operations in channel and spatial dimension respectively.
So now we move on to the implementation part. So we imported the dataset and we defined the mobile net architecture. And after after the model, we got the accuracy as 98%. Then we tried to improve the accuracy also. So we used fine tuning, and in our data set, we were having list of available emotions in the data set were angry for 0, disgust 1, fear 2, happy 3, sad 4, surprise 5, and neutral 6. And this was the count of all the emotion names in our data set. The highest was happy, while the lowest was disgust. So after training the model, we saved the model in our local disk, and now we will run this. Now Apurv will continue.
So finally, I'll talk about the observation and the result of our model. So using the transfer learning, the deep learning model got an accuracy of 98% and a loss of 1.2349. And the received validation loss is around 1.256 and the accuracy of 46%. The accuracy can further be increased with more data instances. The widening of the image must include the faces all around the globe, as the model now is limited to a specific country. That is, the model is biased. Using the OpenCV, we create the bounding box and the display what emotion the person depicts, and the prediction is done in real time by extracting the frame by frame, and prediction is with the help of the build model. The research that contributes to a ton of applications possible for the real world, including real-time crowd emotion monitoring, based off high FPS around 60 frames per second and CCTV and the motion tracking cameras to determine the mode of the crowd at the particular location at a particular instance of time, and accurately tracking the facial and the eye expression with the dynamically generated bounty box perfectly fitting the object and providing the emotion without any delay. Many other applications include lie detection assist and augmented reality, etc. Thank you. Girl.